Are we alone in the universe? K2-18b might change everything we know about alien life. Throughout humanity's long history of exploring the cosmos, one question has always hung above us like the stars themselves. Are we alone in the universe? 124 light-years away from Earth, there is a planet completely covered by deep, dark oceans. And in its atmosphere, scientists have discovered a mysterious gas, dimethyl sulfide, or DMS. On Earth, this gas is almost exclusively produced by living organisms. Even more surprising, the concentration on this planet is 1,000 times higher than what we find on Earth. And because DMS breaks down in just a few days, it must be constantly replenished. Here on Earth, that replenishment comes from life in the ocean. This alien world is called K2-18b. On April 17, 2025, NASA released new observations. They suggest that K2-18b may be the most promising candidate for extraterrestrial life that we've ever found. K2-18b was first discovered in 2015, during the Kepler Space Telescope's K2 Second Light mission. It's about 2.5 times the size of Earth, and 9 times more massive, placing it in the category of a super-Earth. It's neither a gas giant nor a rocky planet. Its density suggests it could be a water world, a deep ocean planet with no land masses at all. In 2017, the Spitzer Space Telescope confirmed that K2-18b lies within its star's habitable zone, the region where liquid water can potentially exist on the surface. Meanwhile, ground-based HAARP spectrometer data indicated a density of about 2.6 grams per cubic centimeter, much lower than Earth's 5.5, but higher than gas giants, again supporting the idea of a global ocean. Then, in 2019, the Hubble Space Telescope detected water vapor in the planet's atmosphere. This was the first time we found indirect evidence of liquid water, linked directly to actual observation, a major step in confirming the ocean planet theory. But the real game changer came in 2023, when the James Webb Space Telescope turned its gaze toward K2-18b. This powerful infrared observatory detected the spectral signature of dimethyl sulfide. On Earth, DMS is primarily produced by marine phytoplankton and microbes. It's what gives the ocean its distinct sea smell. But DMS is short-lived. In sunlight and oxygen, it breaks down within just 3 to 7 days. If it exists, something must be constantly making it. Which means, K2-18b's oceans might be home to a thriving biosphere. To rule out errors and overlapping signals, the James Webb Telescope observed the planet again in 2025, this time using its mid-infrared instrument. Once again, the presence of DMS was confirmed, this time with a concentration 1,000 times higher than on Earth. To sustain such levels, K2-18b would need an ocean biomass thousands of times greater than what we find here. A massive, flourishing ecosystem, operating silently in an alien ocean? Of course, scientists are cautious. They have to rule out non-biological sources of DMS. On Earth, abiotic DMS production is extremely rare. It can sometimes occur in volcanic environments, through high-temperature decomposition of sulfur minerals, but this produces only trace amounts. Crucially, K2-18b shows no sign of sulfur dioxide, a common volcanic gas. Another theory suggests DMS could be formed through photochemical reactions. But simulations show that these reactions are incredibly inefficient. To reach current levels, K2-18b would need hydrogen sulfide levels, millions of times higher than Earth's oceans, and observations show no sign of that. All the evidence still points to the most likely source, life. K2-18b's habitability is also supported by its host star, K2-18a, a red dwarf in the constellation Leo. It's cooler than our Sun and only 1% as bright. So even though K2-18b orbits closer than Mercury does to our Sun, it still receives a similar amount of heat, just enough to sustain liquid water. Scientists have now proposed a new class of exoplanet, Hycean planets, a term combining hydrogen and ocean. These worlds feature thick hydrogen-rich atmospheres, and potentially global oceans hundreds of kilometers deep. There may be no land at all, just a rocky or metallic core beneath the sea. The pressure at the bottom of such an ocean could reach 1,000 atmospheres, far deeper than Earth's Mariana Trench. Despite the compelling chain of evidence, the scientific community remains cautious. Some suggest that K2-18b could be a mini-Neptune, with no true ocean or rocky surface at all, just a gradual transition from atmosphere to liquid metallic hydrogen. Others warn that DMS signals could be confused with overlapping molecular patterns in the spectrum. To meet the gold standard of scientific certainty, the 5 sigma confidence level, we still need more high-resolution data. The upcoming Roman Space Telescope, launching in 2026, may provide exactly that. If life truly exists on K2-18b, it could resemble Earth's deep-sea extremophiles, organisms that survive near hydrothermal vents, without relying on sunlight. In a low-light, high-pressure environment, they may rely on chemical energy, using hydrogen sulfide or methane, in a process known as chemosynthesis. And perhaps, one of their byproducts, is dimethyl sulfide. K2-18b isn't the only potentially life-bearing world out there. There are many others, stranger than we ever imagined, but K2-18b captured the world's attention, because it doesn't just raise the possibility of life, it challenges 3 of our most fundamental cosmic assumptions. First, the universality of life. If a nearby star system just 124 light-years away hosts life, then Earth is no longer special. Second, the definition of habitability. If Hycean planets can support life, the habitable zone may be far broader than we thought. Third, the origin of life itself. If life on K2-18b functions with completely different chemistry, then life might have many answers. From its discovery in 2015, to the DMS detection in 2025, in just 10 years, humanity has gone from philosophical guesswork to scientific evidence. No matter the final outcome, this journey will profoundly reshape our understanding of the universe. As Carl Sagan once said, "If we are alone in the universe, it sure seems like an awful waste of space." Perhaps, in the dark ocean of a distant blue world, life is quietly thriving, just as unaware of us as we once were of them. And we are getting closer to answering the oldest question in the universe. Are we truly alone?